Hi everyone. Today we're going to look at page 47, letter B. 1 plus cosine equals 1/2. Okay, so on this problem, notice that we would be able to solve it if that 1 wasn't there. If it was just cosine equals 1/2, then we would just look at the unit circle, figure out what angle cosine's 1/2 at. So if we can make that equation look something like that, then we can solve it easily. So that's the goal here. Can we somehow make this equation look something like this? Kind of like the last problem, so we can easily solve it. So to do that, we just want to get cosine by itself. So we can solve it like we would a regular equation. We can subtract 1 on both sides. 1 minus 1 is 0, or it just cancels out. We can bring down our cosine. Okay. And now what is 1/2 minus 1? 1/2 minus 1. Remember, you can do it on the calculator, 1/2, or 1 divided by 2 minus 1, or we can solve it like this. So to solve it like this, remember that 1 over 1 is the same thing as 1, so we can write it as 1/2 minus 1 over 1. We want to get our denominator or the bottom the same, so we need to get 2 on this denominator. To do that, we can multiply this fraction by 2 over 2. Because 2 over 2 is the same thing as 1, and we're allowed to multiply any number by 1. Okay, so then we just multiply straight across on the top and the bottom. 1 times 2 is 2. 1 times 2 again is 2. Bring down our 1/2, our subtraction sign. So we got 1/2 minus 2 over 2. What is 1 minus 2? 1 minus 2 is negative 1 over, remember the bottom stays the same, 2. Okay, and if you use the calculator, you should have got the same thing. It might have been seen as negative 0.5, same as negative 1/2. Okay, so now it's asking us, at what angle is cosine negative 1/2 at? I'll rewrite it like that. So now it looks exactly what we wanted it to look like. Now we know how to solve this. We just need to look at the unit circle and figure out what angle cosine's negative 1 at. And remember, if we were going to use the inverse notation, we could also write this as our angle by itself, theta, equals cosine inverse negative 1/2. This is the same thing as this. At what angle is cosine negative 1/2 at? Just different notation. Okay, so let's go ahead and look at the unit circle and figure out where our angle is negative 1/2. So we know that cosine corresponds to the x-coordinate, and we know that cosine in this case is negative, because it's negative 1/2. When our x-coordinate or cosine is negative, we're on the left side of the unit circle. Remember, cosine can be negative 1/2 at more than 1 point, so we want to look at quadrant 2 and quadrant 3. So in quadrant 2, it looks like cosine is negative 1/2 right here at 120 degrees, or 3 pi over 2 radians. Let's go ahead and write that. I'll write our answers in blue over here. So our angle theta can be 120 degrees, which is the same thing as 2 pi over 3 radians. Okay, now let's go ahead and find the other answer. In fact, go ahead and pause the video. See if you can figure it out on your own first. At what angle is cosine negative 1/2 in quadrant 3? Okay, so let's come back. So we want to look at negative 1/2 for cosine, or our x-coordinate. That looks like it's going to be right here at 240 degrees, or 4 pi over 3 radians. So our other answer is 240 degrees, which is the same thing as 4 pi over 3 radians. Cool. So those are our two answers. because at 120 degrees, or 2 pi over 3 radians, cosine is negative 1/2. And at 240 degrees, or 4 pi over 3 radians, cosine is negative 1/2. Perfect. So just as a summary of what we just did, we wanted this equation to look like one of these kind of problems, just a trig function equals a value. So we wanted to get rid of the 1, so we subtracted 1 to both sides. We got cosine by itself equals negative 1/2. And then we just used our unit circle to figure out what angle cosine is negative 1/2 at. Perfect. In the next video, I'll go over problem C, tangent of theta equals the square root of 3. Until then, see ya.